Hello, and welcome to the planning part of the Introduction and Planning Digital Learning module for Siemens Wireless Next Generation, also known as SWING. This training is divided into two videos. In the first video, we introduced the SWING wireless system. In this video, we will focus on how to plan a SWING wireless system. We will begin with some general information, including key planning rules and technical specifications. Then, we will walk you through the step-by-step planning process, showing how to design the wireless system effectively. Finally, we'll wrap up with strategies to optimize your planning, along with key tips for ensuring an efficient and reliable SWING system. Now let's take a look at what you need to know before you start planning a wireless system. Let's start by reviewing some important documents that support the design and planning of your fire detection system. One key reference is CEN TSEN 54-14, a European technical specification. Keep in mind that regional regulations may impose additional requirements as specified in local codes of practice. Additionally, the SWING Radio Fire Detection System Planning document provides detailed guidance. This document can be downloaded from the STEP web client platform using the appropriate document number. Now, let's go on with the planning specifications for a SWING wireless system. There are three key planning rules you need to follow. First, the network size. This defines how many devices can be included in the wireless network. Second, the maximum transmission distance. Each device must be within the allowable range of the gateway or its neighboring nodes. Third, the network density. Every device must have enough neighboring connections to ensure stable and reliable communication. Let's explore each of these rules in more detail. Let's start with the first rule, the network size. In a SWING system, up to 30 wireless devices can be connected to a single radio gateway. Up to 16 FDCW241 radio gateways can be used in overlapping wireless networks. A fire detection system can support up to 16 FDCW241 gateways per loop. The maximum number of devices per loop or stub also depends on the type of fire control panel you're using. For detailed limits and configuration guidelines, refer to the official documentation, FS20 Fire Detection System, System Description, and FS720 Fire Detection System, System Description. Now let's move on to the second planning rule, the maximum transmission distance. In a SWING system, the maximum distance from the gateway to the farthest detector is 90 meters, achieved through up to 3 hops between devices. In open spaces, such as large halls or warehouses, a single radio cell can cover up to 180 meters in total, assuming ideal conditions with no significant obstacles. However, in buildings with multiple walls, the transmission distance is reduced. When there is one standard wall made of materials like concrete between 2 wireless devices, the typical range drops to about 20 meters. In this case, using 3 hops, the total reach from the gateway to the farthest device is generally around 60 meters. It's important to follow the guideline of having no more than one standard wall between 2 wireless devices to ensure reliable communication. The third planning rule focuses on network density. Each wireless device must have at least 2 connections to neighboring devices. This ensures the system can automatically reroute communication if one path is lost or interrupted. The more devices you include in the network, the more communication paths are created, leading to greater stability and higher reliability for the entire system. Now that you're familiar with the SWING system and understand the key rules and requirements, it's time to show you how to plan a SWING wireless system step by step. To begin planning, you'll need a detailed floor plan of the building. For simplicity, this procedure shows a single floor planning example. However, in a multi-floor deployment, keep in mind that the product providing the best coverage may be located on a different floor. SWING planning focuses only on radio devices, so it's essential to identify suitable installation areas. On the floor plan, be sure to mark exclusion zones, such as areas without detectors, like elevator shafts or wet rooms, locations already equipped with wired fire detectors, and structural barriers such as metal walls, solid concrete, or damp masonry. Once the exclusion zones are marked, the next step is to position the radio devices within the usable areas. But before placing any devices, there's one critical prerequisite. All device locations must comply with country-specific regulations. For best performance, place devices in central locations. Corridors are ideal, as they often connect multiple rooms and help distribute the signal more efficiently. To ensure flexibility, always plan with some reserve. We recommend a maximum of 25 wireless devices per gateway to allow for future adjustments. And remember, only radio devices should be planned. Areas with wired detectors must be treated as exclusion zones and left out of the wireless plan. The next key component in the swing system is the radio gateway. For stable communication, the gateway should be installed in a central location within the radio cell. This central position allows it to connect efficiently with surrounding radio devices. Careful positioning of the gateway is essential to ensure a reliable and robust wireless network. Once all radio devices and the gateway are positioned, it's time to check distances and radio ranges according to the planning specifications. Start by identifying the devices that are in a first-hop connection with the radio gateway and mark them. As a general rule, it's recommended to plan for only one wall between two radio devices to ensure a stable connection. Next, using a different color, mark the devices within the second hop range, those that connect via the first hop devices. Then repeat the process, marking devices within the third hop range using a third color. This layered approach helps you visualize the communication path, check the transmission ranges, and track the number of hops. And here's a crucial rule. If a radio link passes through two exclusion zone walls, you must add an additional radio device to maintain reliable communication. After confirming the radio ranges, the next step is to check the network density. A radio network is considered dense enough when each radio device is connected to at least two neighboring devices. This redundancy ensures stable communication even if one link fails. Plan the device placement to maximize first-hop coverage. A strong first-hop foundation is essential for system stability and performance. If the network is not dense enough, you can improve it by adding more radio devices, replacing wired fire detectors with radio versions, or repositioning existing devices in line with local regulations. In a well-designed radio cell, all devices will have at least two neighbors, ensuring a reliable and robust network. Now that we've covered how to plan a swing wireless system step by step, let's continue with some best practices and planning tips to help you design your system more efficiently and reliably while addressing common challenges. When planning a swing wireless system across multiple stories, it's important to note that one radio gateway can cover up to 5 floors, but within a limited horizontal and vertical radius. Start with the floor where the radio gateway is installed, ideally placed on a middle level. On this central floor, you can plan for up to 60 meters of range in each direction from the gateway to the farthest wireless device. Then, continue the planning process on the adjacent floors above and below. Keep in mind, as you move away from the gateway's floor, the effective communication range is reduced, typically to around 40 meters on the immediate adjacent floors and 20 meters on the outermost levels. And here's a key advantage. Network density improves when devices are placed across multiple floors, as they can support each other's communication paths, increasing redundancy and reliability. Let's take a look at how to optimize cross-story coverage in a swing wireless system. One effective method is to split the radio cell into 2 separate cells and repeat the planning process for each. This helps prevent coverage gaps and ensures more reliable communication throughout the building. Positioning radio devices across multiple floors can significantly enhance network density and improve overall system stability. Here's a practical example. In a building with a width of 120 meters, placing a single radio cell across the entire span may lead to blind spots or weak signal areas. Instead, we recommend splitting the radio cells vertically across 5 floors, with a maximum horizontal range of up to 40 meters on the floor where the gateway is located. This approach maximizes vertical coverage and keeps all devices within a reliable communication range. You can further improve cross-story coverage by relocating existing devices, following country-specific guidelines, adding new radio devices where necessary, replacing wired detectors with compatible radio detectors when appropriate. When planning your swing system, always ensure that each device has at least 2 communication paths to the gateway. Avoid relying on a single route. This creates a single point of failure and reduces overall network reliability. To strengthen the system, add more radio devices and make sure every device has at least 2 connection paths to the gateway. This forms a strong foundation for system stability and performance. Additionally, do not combine existing wired point detectors in corridors with radio devices in adjacent rooms. This setup can increase the distance between radio devices and introduce additional walls, making communication within the radio cell more difficult and less stable. Instead, consider replacing wired detectors with radio devices. This solution helps support more radio devices and build secure communication paths, resulting in a more reliable, higher-performing network. When planning in historic buildings, such as castles, you may encounter very thick stone walls, not made of brick, but solid stone. In these cases, the communication route cannot pass through the thick wall. So what's the solution? If you look at these types of buildings, you'll notice that the floors are often made of wood and relatively thin. The best approach is to place wireless detectors on the floor above or below. The connection will then reroute through these detectors, allowing the network to resonate in 3 dimensions rather than staying confined to a single floor. To wrap up, here are a few practical tips to help you optimize your swing system planning. Always plan with some reserve. We recommend a maximum of 25 wireless devices per gateway for flexibility and future adjustments. Position the radio gateway in the center of the radio cell to ensure balanced and efficient communication coverage. Be mindful of exclusion zones, such as elevators, wet rooms, beams, and fire doors. These areas may block signal paths, so plan for additional wireless detectors to maintain connectivity around them. Wired detectors in corridors are also considered exclusion zones. If coverage is needed there, plan them as wireless detectors. Maintain clear paths between devices. Only one standard wall should separate any 2 wireless devices. Avoid narrow or oblong-shaped radio cells, as they reduce signal efficiency and stability. And finally, make sure each wireless node connects to at least 2 other devices to ensure a reliable, redundant communication path. We have now reached the end of our journey through the features and specifications of the Swing wireless system and how to plan it. For more information on installation and commissioning, see the related Swing Technical Digital Learning module.